All right, before we get started on 6.4, we will review our parallelograms one more time. So number 1 tells us that WXYZ is a parallelogram. We need to find the value of x. So a parallelogram is going to be a quadrilateral, meaning that it has how many sides? 4 sides. Okay, so we know that all the angles inside of a quadrilateral add up to what? 360. All the angles have to add up to 360. So what are these 3 angles that they marked with the boxes? 90. So we know that we're taking 3x plus 90 plus 90 plus 90, and we could set that equal to 360. This is not the only way to approach this problem. Today we'll talk about an easier way to approach it. Next step, to solve for x, we would combine like terms. All those 90s add up to give me what? 270.
Would you have to like put 90 plus 90 plus 90, or can you just go straight to the thing?
If you went straight to the 270, I'd be okay with it. If you went ahead and added all those 90s up right away, that's fine. All right, to get x alone, we have to subtract 270 from both sides. We get 3x equals 360 minus 270. $90, thank you. Last step to get x. Divide by 3, x equals 30. So on this one, x equals 30. All right, on number 1, we could have used a different property. What other property could we have used? That would have made it go a little faster. No. What do we know about opposite angles inside of a parallelogram?
They're congruent.
They're congruent. So I could have jumped straight from setting 3x equal to 90 because it's across from it. So multiple ways of doing that problem. You could have jumped straight to 3x equals 90 because you know it's a parallelogram, so opposite angles are congruent. You could have also used your consecutive angles. There are several ways to do that problem. Number 2, there's really just one way to do it. What do we know about opposite sides of a parallelogram? They are congruent. So what equation could I set up? 6x equals 18. How would I solve that one? Divide by 6, x equals 3.
That's it?
That's it.
Ooh, I like that problem.
First, so our lesson today is properties of rhombuses, rectangles, and squares. So our objective is going to be to use those properties. So our objective is to use properties of rhombuses, rectangles, and squares. All right, our first special quadrilateral parallelogram of the day is a rhombus. The definition is a parallelogram with all sides congruent. Parallelogram with all sides congruent is a rhombus. So that also counts as a property of it. It's just not an additional property. It's just part of the definition. Kind of like for a parallelogram, it's part of the definition that opposite sides are parallel. Notice that on all of these, if we are saying that this is a parallelogram, that it has all those same properties that we were talking about last week, and we quizzed on yesterday? Okay, do we remember those 5 properties? No?
No.
We need to start listing them off. In a parallelogram, opposite sides are congruent and
Consecutive.
no.
Opposite.
Opposite.
Parallel.
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 I was just playing.
Opposite sides are both congruent and parallel. What's true about opposite angles?
They're congruent
They're congruent.
and opposite. And parallel.
Oh, be quiet.
Nikitra was trying to say something about consecutive angles for us for a parallelogram. What's true about consecutive angles?
What's the question?
What's true about consecutive angles in a parallelogram?
Equals 180.
They're set equal to 180. They are supplementary. And what's true about the diagonals of a parallelogram? They bisect each other.
They equal each other.
Okay, let's talk about the properties of our rhombus. So on the picture, you could go ahead and mark all the sides congruent. They each get the same amount of tick marks. The first property states that each diagonal bisects a pair of opposite sides. So if I draw in a diagonal, it bisects those angles. So that means up here, this angle is congruent to that angle. And down here, this angle is congruent to that angle. Bisects opposite angles. The opposite angles were congruent to begin with. So both of those little ones are congruent. We can do the same thing going the other way. If I draw in my other diagonal, now I'm creating pairs of congruent angles at the other opposite angles.
We got to do that.
I would recommend it to have complete notes. So that's all for that first property. The second property states that each diagonal is a perpendicular bisector of the other. Now we should already know that the diagonals bisect each other because this is a parallelogram. Right? That's true about all parallelograms. The important part here is the perpendicular part. Perpendicular means what? They intersect to form what kind of angles? Right angles. So in here in the middle, where my purple and red lines intersect each other, those are forming right angles. They are perpendicular to each other. So you can just draw in one, or you could draw in all 4 of them, but these are all right angles in the middle here. I'm not going to draw the bisecting part because that's something we've already learned for parallelograms. The new part is the perpendicular piece. All right, a rectangle, pretty straightforward, something you're probably familiar with. A parallelogram with 4 right angles. Again, all of our properties of a parallelogram would hold true. There is one additional property other than the 4 right angles. That property is that the diagonals are congruent. So in our picture, I would recommend drawing in your right angles. All 4 of those angles are right angles. And then you can do the diagonals one of 2 ways. You could draw them in. It's hard to put tick marks on diagonals. So instead, I'm going to label my vertices A, B, C, D. How would I name a diagonal of this? AC is one of them, so AC is congruent to my other diagonal is BD. So from A to C, if I were to draw in that diagonal, it would be congruent to BD. If you want to actually draw in your diagonals, you can. They just cut through those right angles. Yeah. Maybe like a dotted line. It's hard for me to get them straight through there. It's close. All right. A square, the definition is a little bit longer. It's a parallelogram that is both a rectangle and a rhombus. So it has 4 congruent sides and 4 right angles. It is both a rectangle and a rhombus at the same time. Its special property is that the diagonals form 4 congruent isosceles right triangles, also known as 45, 45, 90s. Anybody remember those?
Yes, I remember those.
Oh, great, David. Okay, so we could, in our diagram, mark all of our sides congruent with those little tick marks again. I'm only going to draw in one diagonal. If you want, you could draw in both of them. I'm just going to put one of them in. You could also put in your 90-degree angles. And I'm just going to mark that these other angles are going to be 45 degrees. So the diagonals form 45-degree angles, making those 45, 45, 90 triangles. So each diagonal would make 2 triangles. If I were to put in the other diagonal, the triangles would be flipped around the other way. Also, I'm going to change my mind on that a little bit, because I'm going to go ahead and draw in my other diagonals. So we could also create 45, 45, 90s using both diagonals. Let's make that a separate picture. I'm going to put that picture over here, up at the top. So if I have another square up here at the top, do we all see my square at the top? Yes, no, maybe so. Up here. Okay, so I'm going to do a second picture for both diagonals at the same time. If you put in both of your diagonals at the same time, then where is the right angle going to be for a 45, 45, 90? In the middle. Go back to your property of a rhombus. Okay, and remember in a rhombus we had those 90 degrees in the middle. We still have 45-degree angles up in the corners. So we've still got a 45 degree here, 45 degree here, 45 degree down here. So there are lots of 45, 45, 90s inside of a square. You've got the big ones when you split it in half, or you come up with these 4 little ones when you put both of your diagonals in. All of these little angles in the corners now are 45s. So if you know that you have a square, you know a lot of information about that quadrilateral. Not just that the sides and angles are the same.
You want us to draw that one at the top?
I would, because you're probably going to see some like this where it's split into the little bitty ones, not just the half triangle ones. I would have both of those pictures. It's a little harder to put them all in one, I think. But if you want to squeeze them all into one, that's fine too. All right, on example 1, it should say on there what type of quadrilateral this is. What does it say this is?
Picture is a rhombus.
It is a rhombus. So we can apply any properties of a rhombus. All right. If it helps you to label the picture first, I would do that with this information. Okay, also filling in your diagram to match this one's, label your vertices, draw in your diagonals, all of those things. They tell us that AX has a length of 12, so I'm going to put a little 12 on AX. It said DX is 5, so I'll write that in also. And that AD, which is the side on the left here, has a length of 13. Before I even look at what they want to know, I like to get my picture all labeled. Once everything's labeled, then we can start looking at what they want to know. So the first thing they want to know is the length of VX. What would it be? 5. We know that because the diagonals are perpendicular bisectors. So they bisect each other, split each other in half. That means that CX, our next one, is 12. It's the other half of the other diagonal. All right, what about BC? Why is it 13?
Because the other side is 13. Like the opposite side is 13.
Okay, so in a rhombus, all 4 sides have to be congruent, so any side of it is the same as the one they told us. Okay, so what does that mean for DB? 10, how'd you get it? You do not have to divide. You add them up. We already said that DX is 5. They told us that. We figured out that BX is 5. 5 plus 5 is 10. What about AC? 24. Again, the whole diagonal would be the sum of the 2 little pieces of it. Finally, DC.
17.
DC is what?
17.
13. Why is DC 13? In a rhombus, all sides are congruent. So if one side is 13, all the outside sides are 13.
Oh, I was
Okay, they tell us that this one is also a rhombus. So we will still be applying our rhombus properties. Give you a moment to get your picture labeled. One thing I want to mention is these 1, 2, 3, and 4. Notice that they do not have a degree symbol on them. So those are just their names. So instead of having to use 3 letters to name each of those angles, they just put in 1, 2, 3, and 4. We okay with that being their names, not their measures? All right. Inside of a rhombus, we first need to know the measure of angle 1. Anybody know what it would be?
32.
Why?
Because they're all congruent.
Not all the angles would be congruent. I agree that it is 32. I just don't agree with the reason why. So we need to figure out why measure of angle 1 is 32 degrees.
They're on the same side.
We cannot go based on looks. Not an option. I would consult my properties of a rhombus that I just wrote down on the front if I am unsure. something about those diagonals.
Each diagonal bisects a pair of opposite angles.
Wonderful. Each diagonal bisects a pair of opposite angles. So one has to be the same as the one that's next to that same diagonal. Okay. What other two angles on here are going to have to be the same?
3 and 4.
3 and 4 will also have to be the same. So once we find 3, we can write the same thing down for 4. Okay, the diagonals bisect the opposite angles in a rhombus. What about angle 2? Ken?
90.
90, why?
Because it's right angle.
Why? Somebody else can help out. What special word did we use about the diagonals of a rhombus?
It bisects.
Perpendicular was the special word we were looking for there. Perpendicular means that it forms those right angles. All right, now we already talked about that 3 and 4 have to be the same, but how are we going to figure out what they are?
Well, 4, I believe, is gonna be 90. No, never mind.
You're on the right track, but we won't use 360. Why 180? Let's look at these angles that we already know. We already know 1 and 2. If we look at 1, 2, and 3, they all lie inside the same. What shape is this?
That's a triangle.
That's a triangle. And we know that all 3 angles inside of a triangle should add up to 180. So if we know that up here we've got 32 degrees and in the middle we've got 90 degrees, can we find the third angle? We subtract these two from 180 and that'll give us our last angle. We have to remember to still use properties from previous chapters. If I take 180 minus 90 minus 32, what do I get? 58. So the measure of angle 3 is 58 degrees. And the measure of angle 4 is also 58 degrees. We talked about the fact that we know those two had to be congruent. Okay. I'm going to erase what I drew in here so far. Now on the next one, we want the measure of angle KTN. All right, next we are looking for the measure of angle KTN. That is this whole big angle up here. The whole thing, not just a piece of it. Any ideas on how we could figure that one out? Jaden?
58.
Measurement 3, measurement 4.
Very good. This angle up at T, the whole big angle at T, is going to be congruent to the whole big angle at E because this is a parallelogram. So if we add angles 3 and 4 together, that'll give us the measurement we need. 58 plus 58 is 116 degrees. Questions about measurement of KTN? Okay. I'll erase that. Last, we need the measurement of angle TNE. So TNE is the whole angle up here at N. How could I find that? Jaden?
Add measurement 4, not 4, 3 to measurement 1.
I think you're making it harder than it needs to be. What do we do, Jordan? Add angle 1 to what? Angle 1 and 2?
What? I'm so confused. I'm sorry, I didn't see 2 in the middle.
What would you do, Ken?
I would add angle N and angle E together.
I disagree.
One wrong.
I think everybody is making this harder than it is. What is the measure? Thank you, Nikitra. We add 32 to 32 and we get 64 degrees.
Dang. Smart.
What type of shape do we have now? A rectangle. Rectangle ABCD. That would be point X in the middle, where our diagonals cross each other. Now, just because we were talking about rhombuses on the last two problems, I want to bring something up. Are we going to have 90-degree angles in the middle on a rectangle? No. Okay, so don't confuse the properties of a rectangle with a rhombus. In a rectangle, you will not have 90-degree angles in the middle. Where will your 90-degree angles be? In the corners. Okay, we don't need them on this one because all they're asking for are sides. I just wanted to make sure we understood that. Okay. First, AC is going to... Actually, AC is one of the hardest things we have to find. Let's skip to DC first. What's the length of DC going to be? 4. Why?
Because it's congruent to AB.
Okay, opposite sides are congruent to each other. This is a parallelogram after all. All right, BD, we're also going to save because it's another diagonal. What about AD? AD would be 3. What do we know about AC and BD, though? What do we know about the diagonals? They're congruent. So if we find one diagonal, we know the other one's got to be the same. Does that make sense?
Yeah.
Okay. So let's work on finding AC. If I'm trying to find AC, I am going to, just for the sake of this problem, get rid of this little piece right here. And I know that this angle up here at B is a right angle. All right, if you can't quite see where I'm going with this yet, I erased part of that diagonal and put in my right angle. If you're still not sure where I'm headed with this, I'm going to go ahead and take away the other side of the rectangle completely. What am I left with? What is it? A right triangle. I'm left with a right triangle where I have 2 of the sides, and I'm trying to find the third one. Jaden? Pythagorean theorem comes back again. Okay, so on this one, if I'm labeling them A, B, and C, which side has to be C?
C. I mean, this side. What else?
AC, the side that's not labeled. So that's going to be my side C. My other 2 I could label A and B. Does anybody remember that magic formula that we're going to use?
Squared plus B squared plus C squared.
A squared plus B squared equals C squared. So I plug in my A and my B. 4 squared. 3 squared. 16 plus 9. Jaden? 16 plus 9?
No, the answer's 5.
Okay, I asked for 16 plus 9. Children? What do I have to do to get C alone? Square root, and as Jaden has been trying to tell us, it's 5. So that means that AC has a length of 5, which means that BD also has a length of 5. Okay, so I'm going to bring back our original picture here. All right, last but not least, we are asked to find CX. It will be a decimal. What is it, Jordan? 2.5. Anybody know how Jordan came up with 2.5? She divided 2?
No,
What is it, David?
Tell us the answer,
It's
Jacob.
half of 5.
It's half of 5. The diagonals bisect each other because this is still a type of parallelogram.